Okay. Boys and girls, watch this. When I stood in front of you guys, I don't know, before Oaks Park, we talked about resonance, didn't we? Yes, we did. Okay. And with resonance, the deal was that if you drove a system at its resonant frequency, the amplitude would get quite high. Okay. So this notion is like this. Here's this resonant frequency, and I'm just pumping energy into it at its resonant frequency, and of course it gets going pretty good, doesn't it? Yeah. What I did not tell you was that if you've got a medium that waves can travel along that is like finite in extent, okay, there's more than one resonant frequency. Watch this. That's 1 and 2 and 3. So if I double that, ooh, look at that. There you go. Right? This is called a standing wave. It's not really standing. Okay, it just appears to be standing. It's an optical illusion. How it works, I'll show you in a little bit here. Okay, notice that there's a point in the middle. This is called the second harmonic of this thing. Right? The first harmonic was that first one you saw. It's pretty straightforward. Right in the middle, that spot that's not moving is just twisting. It's not moving up and down. Right? That is called a node. Now, if you read the book before today, you probably already knowed that. Right? Now, there's 2 more nodes. Where are the other 2 nodes on this pattern? Yeah, the ends. This is sort of a node where I am, right? A node at that end for sure, right? So these are, by the way, called the boundary conditions of this thing. This end is fixed, that end is fixed, and this is one of the possibilities. And then if I could do 3 against 2, right? There we go. Right, so this is like, if you are musically oriented, right, this is one of the things, like a conductor's got to be able to go instantly from duple to truple or whatever, no, right? 3 against 2 or whatever, right? Triplets, right? Okay, it's like, whoops, it's tilting, stop tilting. There you go. And then this is the 3. How many nodes are there in this one?
4.
2 in the middle, 2 at the ends. Sorry. There we go. Okay, how about, let's see if we can get 4. Here, it's like tilting. Stop tilting. Here we go. Let's see if we can get 4. Is that 4? Let's get 5. 5. How many is that?
1, 2, 3, 4, 5.
Yeah! So, I think you know that it's a certain frequency. That's the way resonance works. There's a certain frequency, and by the end of the day, you'll be able to calculate that frequency. Right? Okay. You know, why is that important? Well, I don't know. It's on the IBI test. There's other reasons, you know, but there it is. Right? Oh, no, well, okay. Here's another reason. The geometries that we're going to discover with this are the basis of all chords and music theory. How's that? Is that pretty good?
Yeah, I like it.
There you go. Yeah. This is why you're going to discover in the next 2 or 3 days why it sounds good to play a C, a G, a C, and an E. It's like this rich chord. Why that works? Because those are the notes that I played there. One of those was the fundamental. That might be the C, right? Anyway, that's where they come from. Okay. Now, the question that you might have is hello? Okay. First off, you know, these are the patterns that you get, right? And the first question you might get is, how is it that this happens, right? So let me just show you this, and I can show you this. I've got a really cool way to demonstrate this. Okay? Gentlemen, can you not carry on the side conversation? Okay? So let me just I'm going to draw this one here because this is the best one, right? Let's say we've got this mode going, the 2-hump-wump or whatever we want to call it, right? Now, by the way, this is a full wavelength. That's what a full standing wave looks like. It looks like 2 footballs, kind of like that, right? Okay. Now, what we need to understand is that if this wave kept going, it'd just look like this again, wouldn't it? Only it would be better drawn because that wasn't really very good. Anyway, but it doesn't keep going, does it? So what it's actually going to do is it's going to reflect off of this fixed end, isn't it? Now, when you reflect off a fixed end, what happens? Yeah. Are you upright or inverted? Yeah, fixed ends inverts. So this reflection here at this point doesn't continue. In fact, it's going to reflect back on this, and it's going to be inverted. So this dotted line is going to be reflected back on this. Now, to better help you visualize this, okay, I can do the following. First, I'm going to take my magic wand, and I just made that transparent. Isn't that cool? That is amazing, right? Okay, then I'm going to get my chainsaw. I'm going to go. Holding it there, it's going to fall down, right? I get my screwdriver out. I put the hinges in there, right? Yeah? And I'm going to take this one, catch the edge there. And I'm going to fold it back on top of there so you see, so you visualize in your head that this part here, isn't that going to fold back on that one? And this one's going to fold back on this one. And this part here is going to fold back on this one, not there, right? Over there, right? Yeah? So isn't this trough meeting trough, nothing meeting nothing, crest meeting crest? What kind of interference is that? Constructive or destructive are the two possible. This is constructive interference, right? So a standing wave is one where it interferes constructively with its reflection. Now it's actually a little bit more complicated than that, because if I slide this wave forward another half cycle or something like that, right? What's going to happen? Well, a half a cycle would do that, but what about a quarter cycle? Well, gee, isn't it going to be then totally destructive? Yeah? And then isn't it going to be just constructive the opposite way? Won't it be? And then totally destructive and then constructive the other way? Yeah? Is that what it's doing? Is that what it really does? Does it go level in between? Oops. Stay. Does it go level in between? Is that the fundamental? It's like, I think so, doesn't it? Yeah, if you had a fast enough camera or something like that, this thing would be straight flat in between, right? Kind of hard to picture that, right? But it has to be, because they're both moving. When one side's moving down, the other side's moving up. They must go through level to then go the other way, right? Okay, so yeah, that's what's going on, and that only happens at particular frequencies, and that's the whole goal here, is to figure out what those frequencies are. Okay, so let me show you more standing waves. Okay, this was both ends fixed. I can do that on the wave motion demo, but what I can't do is I can't do like both ends free. It's like I can't take this end off of there and then, oh no, that doesn't work, right? Okay, but with this thing, okay, with this guy here, I can do both ends free because it's a weird twisty sort of thing, right? Stay, right. All right, so here is both ends free, and with both ends free, we get these modes. Here's the fundamental. There always has to be, by the way, one node. Kids always want to make both ends free. They want to make like this is the fundamental. Look, fundamental. No. It's got to be at least somewhat twisty, right? Right? Doesn't this look like that first drawing up there? Yeah, convince yourself that that's what it's doing. There's a node in the middle, right? You already know that's what it was called, though, right? Right? Which means if this were sound, if we could set up a sound wave this way, right, then there'd be a spot in the middle where if you put a microphone there with this, the air wouldn't be moving. You wouldn't hear it. That's kind of weird. That's true, right? Okay, the next mode, I can get that next mode there. Watch this. And now you've got how many nodes? 2 nodes. This is, by the way, a quarter of the way in. Another quarter there, right? So if you're drawing these, you should draw these in your notes, I think. Right? If you're drawing these, make them all the same length, and this helps you draw, right? This is a quarter of the way. A whole football there in this case is half the wavelength, right? How much of the wave is here? Is this all the wave? Are there 2 full footballs on this one? Yeah, I think there are, right? Okay, there's a football here, and then there's 2 half footballs. We could cut that one off and put it on there. That would look like this. No, just kidding. Okay, are we ready for this? Are we ready for the next one? It's like